and welcome guys, welcome back to my channel. Today we are going to discuss about a real life example of how Z-buffer algorithm is really helpful in showing us the video games which we play in today's life. So yeah, in the previous video if you have seen that I tried to explain you the Z-buffer algorithm with an example of some planar shapes. But today we are going to see a example, more better example which is more understandable to all of us. I'm going to explain it with the help of this blog written by the Racket Boys. See, this blog is trying to explain us how Zbuffer helped us to shape the video games which we see today. See, earlier in the history, you all might have played the game Super Mario, right? It's a 2D platformer game. So that 2D platformer game we all played, it was very famous, right? But in today's games, whatever games we play in this, all the games which are released right now, currently, are all having the 3D characters, 3D scenes, right? But what was there in Super Mario? Super Mario was all flat, that you can see Mario running and or in a flat plane, and there are some other enemies coming which look like you are playing on a drawing sheets, right? That some drawing characters are going on and you are playing. They all look 2D images, and Mario also looked 2D image. There was no information of depth there present itself. But in today's time, if you play the Super Mario game, then you can see Mario in 3D shape and platforms like real world spaces which we see in our day-to-day life. 3D, all 3D coordinates are there. So how it is done? How is it possible to make all 3D scenes and all the characters with volume to come into play? It all happened successful due to the Z-buffer algorithm. How? For motivation, I'm going to show you the scenes of Genshin Impact game as an example for 3D games. So here is the picture of one of the scenes of Genshin Impact game. You can see that there is a wide, beautiful area spread all over, and this is the character. So this character, you can see she's having volume, and you can see the three coordinate, three dimension scenes here. If you want to see the characters more precisely, this is an image of the character of Genshin Impact games where you can see they are all having volumes. This video, if you are not aware of this game, then this video trailer I'm going to pin it in the description box. You can all see it as an example for Z-buffer algorithms reading importance more. So understand the importance of Z-buffer algorithm which you are learning right now. Yeah, coming back to the example. Yes, so we come back to the example. Here in this example you can see that this is a simple 2D planes which I tried to explain in the previous videos as well, but with the help of this example today I'm going to explain it related with this Genshin impact scenes. So first of all, let us first keep things simple and understand with the plane shapes again. You can see this, I told you earlier that this algorithm is using is keeping two different directories. Simultaneously, it's updating two different directories. One, which is carrying the z-axis information, that is, it's carrying how much deep or how much volume this shape is having. And the other directory yeah, z information directory is the depth buffer memory, and the information of what color I'm supposed to paint in the fit photograph in your digital screen. so that you can understand this is one shape or this the other one is there is other shape. So other directory is referred to as refresh buffer memory. You can see this is the three-dimensional plane in the 3D world coordinate, and this is your TV screen, or you can say your computer screen. So this 3D scene is being projected to your computer screen, and now on the computer screen it looks like this. So this is an orthographic projection. If you all do not know what's an orthographic projection, then I will pin some videos in the description box to give you some basic understanding of what is orthographic projections. Right now you can continue this video if you already know or you have some basic information of projections. What are the types or kinds of projections used for projecting an image to see it digitally, or you can come and or you can go and learn about some projection algorithms and how things get projected on the screen, and then you can continue looking at this video again. So yes, to make this screen projectable, you can see that this triangle is overlapping with some parts of this green square and then some parts of this blue circle. So how this information is getting stored in the computer? Yes, this all this 00 thing is the Z buffer, uh, that is the depth buffer and the refresh buffer information stored here. See in this example, the depth buffer and refresh buffer is being stored together. It is being shown in one matrix only, but in the computer there are two separate information memory being simultaneously being updated as soon as one image or one plane is being detected. So yeah, so say suppose that first this S1 circle came, the information of S1 came that S1 is supposed to be displayed. Then you have all this, you can imagine this all this whole, not the whole exactly, this matrix is storing the pixels location where it has to be shown as S1 circle plane, and at what depth it is there. Say suppose some 5 some any arbitrary value, say suppose 20, say suppose this is 20, and mind you this 5 is not for the depth value, this 5 is for the color, blue color. And then you come back and see that S2 square you wanna show on the screen, and some portions of this square is overlapping with this blue color. Then this blue matrix will be updated to some only this portion, that these pixels 1 2 3 4 1 2 3 12, these 12 pixels is showing the information of square, and that is of color green. So you are seeing that there is a green part in the matrix and there is some blue part on the leftover pixels. Then again this S3 plane is coming, that you have to show this S3 image and the S3 plane. Then all these portion that S, you understand that uh, S2 plane, that is the green square, in the Z depth it came out to be 10, and the circle was in 20 space, 20 spaces in the world coordinate it had. So computer understood and updated that this square, green square is above this circle. Then say suppose this red triangle is in location number 5. So this triangle is above it, all these two surfaces, that is square and this circle. Then all the places wherever there is all the pixels wherever there is, have to show this triangle being on the screen, I have to show it in red color. So You might be thinking all these plain squares, again I'm saying, then how it is helping me show the scenes of the 3D scenes which I was talking about. So you can now let us imagine and relate it with this game scene. So now let us think that that blue circle what I was talking about is suppose the information of sky, where you have to show the sky. All these pixel information must have the color blue to show me that this is the sky in the scene. And then say suppose the character moves in front and you can see that this mountain and these lands all are there in the scene, and I have to show it in the scene simultaneously. So very fast computer have to analyze that all these pixels on the screen, all these pixels on the screen must be blue, but these part of the pixel must be colored of the mountain and the green terrains and these grasses and all these trees must be there. So it have to compute very fast in real time to make us know that yes, this is a yeah, that this is a greenery see mountain scene with very beautiful sky. And then suddenly you can see that we know while we were playing, we can see the character coming in front. We can think it as the example of the triangle plane which we were talking about, that this triangle is coming before even this mountain. Some parts of this mountain and sky I have to show this character, the that this character is coming in front in my game scene. So very fast it has to color code the all the features of the character. So you can understand how much complex it is to analyze, and I'm only taking the example of mountain and sky and the character, but you can see there are even more minute details, that small trees and some fog is there. All this information, so many information is coming and very quickly getting combined to show me this gaming scene, and I make me feel that I'm in a virtual 3D world. So all this came became possible due to the Z buffer algorithm. So let us play our let us play all the games which we love to play and be thankful to this algorithm. So yeah, that was all for me from my side today. So this blog mainly now speaks about that how the hardware got changed and how Z-buffer algorithm helped us to make the 3D games, 3D scenery, 3D sceneries in the 2D image, 2D computer screen or mobile screen, or you can say your TV screen. So, in the history, why it was not possible for the Mario game that only 2D platformer was easy to compute? Because when a Mario game was released, Mario game used its scenes to be shown that by using the sorting algorithm. That before this coming of Z buffer algorithm, all the information of Z information was getting updated by sorting, say suppose from increasing to decreasing value of z, then every time I'm saying that, for example, every time I was telling to say my character is moving in front, then every time I have to update my list and again I have to sort the whole list, and very quickly I have to show it on my screen, that and I have to simultaneously update the color information as well according to it. So it was getting very difficult for the hardware to show it in real time. It would be like my game is getting buff and that I'm showing so much buffering in my game. So all the hardwares were changed and modified to very quickly integrate all the information in one scene and show it in real time like I'm really moving in the game. So thank you all. That was all from my side today. We will meet in the next video. Till then, have happy learning, be happy and live and try to be better than what you were yesterday. And okay, thank you. Bye bye. Thank you for watching my video till the end. If you like this video, please hit the like button. If you loved our content of our channel, then please subscribe to our channel.